Welcome to The Explainer. Today, we're diving into something that is absolutely going to challenge how you view the entire universe. I want you to start by thinking about this sort of philosophical hook. What if the mathematical equations we scribble down on a chalkboard don't just describe the reality around us, but actually predict a reality before it even exists?
The universe is 13.8 billion years old, vast, ancient, and mostly invisible. And somewhere out there are answers to questions that keep scientists awake at night. Welcome to our channel, where we explore the darkest corners of the cosmos, the mysteries, the threats, the unknown. This is space like you've never seen it before.
It's a pretty heavy question, right? See, we usually think of physics as just a process of observation. You drop an apple, you measure how fast it falls, and then you write an equation for gravity. But consider this. Can math act like a cosmic crystal ball? Because what's absolutely fascinating here is that antimatter wasn't discovered by accident in some lab by scientists mixing chemicals or smashing atoms together. No, it emerged entirely from pure abstract mathematical thought. It was literally a ghost in the numbers, long, long before it was ever captured in reality. All right, Section 1, the physics crisis, clashing theories of the universe. Okay, let's dive into this. To really grasp the origin of antimatter, we have to travel back to a massive, massive crisis in early 20th century physics. Basically, we had these two brilliant but wildly incompatible ways of looking at the universe. On the left side, we've got quantum mechanics. This is the weird, super probabilistic physics of the very small, all governed by wave functions. And then over on the right, we have Einstein's relativity, the physics of classical limits, gravity, and objects moving close to the speed of light. And these two pillars, they famously absolutely refuse to work together. A perfect real-world example of this clash is the gold anomaly. To explain why gold has that distinct yellowish color, you can't just use one of these theories. You actually need relativistic quantum chemistry. The speed of gold's inner shell electrons approaches the speed of light, which means you need both quantum mechanics and relativistic effects working at the exact same time, just to explain its color. But mathematically, combining these theories was an absolute nightmare. The equations just kept breaking down. Which brings us to Section 2, Paul Dirac's prophecy, merging the impossible. Enter physicist Paul Dirac. This guy was a true visionary who looked at this impossible clash and just decided, you know what? I'm going to force quantum mechanics and relativity into one beautifully unified equation. He was determined to map exactly how an electron behaves when it's moving near the speed of light. And to pull this off, Dirac fractured the relativistic energy-momentum relation. Now, this was an immense mathematical leap. It actually required using complex mathematical matrices called spinors. But when Dirac finally solved his equation, it worked perfectly. Except it produced this bizarre, deeply unsettling anomaly. Think of it like this. Just like the equation x squared equals 4 has two valid mathematical answers, a positive 2 and a negative 2, Dirac's equations spat out a negative energy root that couldn't just be ignored. His math was literally predicting states of negative energy. Now, instead of just throwing the math out, Dirac trusted it. He proposed what's known as the hole interpretation. He suggested that what we think of as an empty vacuum is actually a sea of infinite negative energy, and an empty hole in that sea would appear to us as a particle with a positive charge. He had essentially predicted a perfect mirror image of the electron. Moving right along to Section 3, fulfilling the prophecy, from math to the lab. Now, what's really interesting about this slide is seeing how pure math sparked a real-world physical hunt. With that single equation, Dirac had essentially drawn a treasure map for a particle that literally no one had ever seen, using only the immense power of his mind. Let's walk through this timeline. Throughout the 1920s, quantum mechanics and relativity are established, but they're totally separate. Then, in 1928, Dirac writes his infamous equation predicting these strange negative energy states. For 4 whole years, it's highly controversial. Many brilliant physicists at the time thought it was just a mathematical artifact, right? Just a glitch in the numbers. But then fast forward to 1932. Physicist Carl Anderson is studying cosmic rays. He's looking at cosmic ray tracks in a cloud chamber surrounded by a super powerful electromagnet. And suddenly, he notices a particle track curving in the completely wrong direction for an electron. By measuring that specific curve, he mathematically proved the particle had a positive charge, but with the exact identical mass of an electron. Anderson had discovered the positron. This was an absolute empirical shock to the scientific community. He had literally photographed the exact particle Dirac had conjured out of pure math 4 years earlier. Dirac's wild, highly controversial prophecy, it was completely, undeniably real. Section 4,
the nature of antimatter, mirrors, and collisions.
So, the crucial point is, what exactly are these particles? Now that we knew for sure antimatter existed, physicists had to figure out how it behaved in a universe that's made mostly of regular matter. Best way to think about it? It's like a perfect yet incredibly hostile mirror. The symmetry is just precise. Antimatter has the exact opposite electrical charge, but the identical mass to normal matter. And it doesn't just stop at individual particles either. You can actually form complete anti-atoms, like antihydrogen. Physicists have successfully done this. But here is the kicker. Whenever matter and antimatter touch, they annihilate each other violently. They convert 100% of their mass directly into pure energy, making it universally the worst possible handshake.
Which leads us to an incredibly practical problem. This right here is the ultimate containment challenge. How on earth do you study or store a substance that will instantaneously destroy itself and the container you put it in the very millisecond they make physical contact? You obviously can't just put it in a glass jar. You have to use what are called pinning traps. These are devices that use extreme magnetic and electric fields to suspend antiprotons in a pure vacuum. That way, they touch absolutely nothing.
Section 5. Fueling the Future. Energy and Space Exploration. But hey, that massive, explosive annihilation energy, that is exactly why antimatter isn't just some theoretical curiosity for physicists. It is quite literally the holy grail of fuel. The efficiency of an antimatter engine for deep space exploration would just be totally unprecedented. Just a tiny, tiny amount could take us out to the outer planets in a fraction of the time it takes today. But of course, there's a catch: the astronomical financial cost. Right now, we can only make it a few atoms at a time inside massive particle accelerators. Producing just 1 single gram of antimatter is estimated to cost around $62.5 trillion. Yeah, trillion with a T. That makes it the most expensive substance on Earth by a staggering massive margin.
All right, Section 6, the Big Bang Glitch, Lingering Cosmic Mysteries.
So, obviously, we can barely afford to make it now, but at the very beginning of the universe, it was everywhere. And this brings us to the most mysterious part of this whole explainer, what physicists formally call baryon asymmetry, or, the Big Bang glitch. Mathematical models absolutely dictate that the cosmic event of the Big Bang should have created an exact 1-to-1 ratio of matter to antimatter. Just equal parts. But if it was exactly 1-to-1, all that matter and antimatter would have completely annihilated each other in the early universe, leaving absolutely nothing behind but light. Yet, look around. Reality tells a very different story. We exist. The universe is characterized by complete matter dominance. Somewhere, somehow, for every billion antimatter particles created, there was 1 extra billion in 1 particle of normal matter. And that tiny, tiny asymmetry is literally the only reason you, me, and all the galaxies exist today.
To try and explain these wild behaviors, scientists have proposed some truly mind-bending ideas over the years, and this brilliantly illustrates one of the best ones, which stems from the Feynman-Stuckelberg interpretation and CPT symmetry, charge, parity, and time. It's Richard Feynman's time reversal theory. Mathematically speaking, a positron moving forward in time is entirely indistinguishable from a normal electron moving backward in time. Let that sink in for a second. Feynman suggested that antimatter might literally just be regular matter traveling in reverse through the temporal dimension.
Which leaves us with this final, lingering thought to wrap up on. If antimatter really is just matter moving backward in time, and we know equal parts were theoretically created at the dawn of the Big Bang, where did it all go? Did it all just annihilate? Or is there an entire mirror universe out there made entirely of antimatter, moving perfectly backward away from the dawn of time? It's a question that started as a strange little mathematical anomaly on Paul Dirac's chalkboard, and today it remains one of the greatest unsolved mysteries of our reality. Thanks so much for joining me on this explainer, and as always, keep questioning the universe.
The universe doesn't care about us. It never did. But we care about it. And that is what makes us extraordinary. If this video made you think, hit like, share it, and subscribe to this channel. Because the next mystery is even deeper. Until then, stay curious and keep looking up.